Hi, this is Professor Ridge. Welcome back, and today's lesson is on section 8.1, quadratic equations. So basically we're picking up where we left off in chapter 5.8. We solved quadratic equations. And if you recall, so this is from 5.8, I asked you to solve x squared plus 4x plus 3 equals 0. The technique was by factoring. You get it equal to 0, which it is. Then you set each, or you factor it. So if x3, add to 4. Put in your signs, and then you set each factor equal to 0 using the zero product principle or zero factor principle. And then you solve each of those separately, and we get the two solutions, -3 or -1. Now the problem is, what if I ask you to solve x squared plus 5x plus say 3 again. So what if x3 they added 5? Well, there aren't any. You can't factor this. So you're stuck. Okay, so we need other techniques, and in chapters, and we had to learn about square roots and do some other work first before we can get back to solving these equations. So from chapter 7, we introduced this idea of principle of square roots. So let me write that down. Okay, so if x squared equals k, then x equals the square root of k, or x equals negative square root of k, the opposite of square root of k. And if, since we learned about the imaginary number system, we can take the restriction away that k has to be positive even. So it could be anything. Alright, so we want to develop this technique so we can solve that problem up there from 5.8 that we can't factor. So we want another technique. So here we go. So we're going to use this principle of square roots. So example 1 that I just made up. If I said solve x squared equals 49 using the principle of square roots, you're going to square root both sides. X equals square root of 49, or x equals negative square root of 49. So it's 7 or negative 7. Now we could have solved it by getting it equals 0 and factoring it, but you see this is a lot quicker. So this is actually a great technique. You can't forget to put the plus or minus. Remember, we get two solutions. So now if we did it by factoring, right, you got the difference of squares, x plus 7, x minus 7. So x equals negative 7 or x equals positive 7, which gives the same solution. Okay, so either technique's fine. But again, we're trying to develop a new technique for things that don't factor. So it turns out if I give you, say, x squared equals 12, well, that one wouldn't factor. But with this technique, we can say, well, x equals, you square root both sides, x equals square root of 12, or x equals negative square root of 12. And we learned how to deal with these square roots. So 12 is 2 times 2 times 3, so 2 comes out, 3 stays inside. Now just for shorthand, what we're going to do is you're going to square root both sides, say x equals plus or minus square root of 12. Okay? So that symbol means the same thing as splitting it up into the two equations. So it's plus or minus square root of 12, which simplifies to plus or minus 2 square root of 3. So that means the same thing. Okay, so those are the same thing. Right, so now our next step is, okay, so instead of if we think of this x plus 5 as one number, as just another variable, so it's something squared equals 17, I can still use this idea of this principle of square roots, square root both sides, and I get x plus 5 equals plus or minus square root of 17. Okay, and then for me to solve for x, I'm going to subtract 5 from both sides. But since negative 5 is not like terms with the square root of 17, I just write them down. And that's my solution. So note this again, this is shorthand for x equals negative 5 plus square root of 17, or x equals negative 5 minus square root of 17. Okay, so those are the same thing. So be careful. Okay, so again, I'm going to use this principle. If I have something squared equals a number, I'm going to square root both sides. So the square and square root cancel each other. And then I'm going to get the plus or minus square root of 49. And then I'm going to, now that one simplifies. So this is x minus 3 equals 7. X minus 3 equals negative 7. So I'm going to add 3 to both sides, so x equals 10, or x equals negative 4. So I get the two answers. So if it simplifies, go ahead and split it up and then do the two answers. All right. So again, now we're kind of building to that first one, x squared plus 5x plus 3 equals 0. So our next step is, let's take a little side journey here. Our goal is we want to get something squared equals a number. So if I had x squared plus 6x plus 9 equals, say, 7. If I notice that this is the same thing as x plus 3 squared, right? I want to write it as something squared. So that's nice. Okay, and then I square root both sides. X plus 3 squared is x squared plus 6x plus 9. So I can substitute x plus 3 squared for that trinomial. Okay, then now I have something squared equals number. I square root both sides, so x plus 3 equals plus or minus square root of 7. Then I'm going to subtract 3 from both sides. Negative 3 is not a square root, so I can't combine it. They're not like terms, so I just write them both down. And it's simple as that. Now, here's the problem though. What if I had x squared plus 6x plus 1 equals 0? How would I make this work? How can I get it something squared as a number? So the idea is I'm going to subtract the 1. And if this was x squared plus 6x plus 9, I'd be in business, and that would be the same thing as x plus 3 squared. So for the left side to be equal to x plus 3 squared, I have this missing term that needs to be 9. Now, can I just add 9 to one side of the equation? And the answer is no. But if you add 9 to both sides of the equation, then you're okay. Then you're in business. So now the left side is x plus 3 squared, and the right side is 8. Then you square root both sides. So you get x plus 3 equals plus or minus square root of 8. Then you subtract the 3, plus or minus square root of 8. And you're done. Oh, well, you got to simplify it. Plus or minus 2 square root of 2. Now we're done. Okay. So, what I want you to learn is about completing the square. I usually say fill in the blanks. So if I had x squared plus 4x plus blank equals, here, let me put it over here, equals x plus what squared. So the technique is you're going to take this middle term, divide by 2. So 4 divided by 2 is 2, and then you're going to square that, and that's 4. That's how you do it. So if I have x squared plus 10x plus blank, that equals, so again I'm going to take the middle term, divide by 2, that's 5. 5 squared is 25. Okay. So if I have x squared plus 20x plus blank equals x plus, divide by 2, that's 10. 10 squared is 100. Okay, that's the process. That's how you complete the square. All right, let's do one more. X squared plus 5x plus blank equals x plus blank squared. So again, I'm going to take the middle term, divide by 2, so that's 5 halves, or 2.5. 5 halves squared, you just square the top, square the bottom. And that's it. 25 fourths, or 6.25, either one. All right, so let's see if we can solve one using this completing the square technique. Okay, so again, your first step is get rid of that constant term. So we're going to subtract 5 from both sides and leave a blank there. Remember, x times x is x squared. We're factoring this trinomial. We're using the idea of a perfect square trinomial. This is the completing the square technique. So again, we're going to take the middle term, divide by 2. So 12 divided by 2 is 6. And then 6 squared is 36. And you can't just add 36 to one side without adding it to the other. So we add it to both sides. Okay? And then you combine the 3 terms on the left is the x plus 6 squared. And then on the right, negative 5 plus 36 is 31. And then from here, it's always 2 steps. You square root both sides. Don't forget plus minus, square root of 31. And then you subtract the 6. And you don't have to show this work, just put it in front. So equals negative 6 plus or minus square root of 31. Okay, so again, if you use the shortcut, you change it to the other side. The positive 6 on the left side becomes a negative 6 on the right side. And just put it in front of the plus minus sign. So it'll be negative 6 plus minus square root of 31. And then the only thing left from there is you got to see if you can simplify it, which this one doesn't. Okay. So let's try another one. Well, let's do some exercises. And we got to build. Notice all the ones we've been doing, we had a number in front. So let me do one more. So let's say if I had 4x squared plus, I don't know, let's see, how about 40x plus 17 equals 0. Okay, so our first step is subtract that 17. Now, instead of trying to make this a perfect square, which we could do, it'd be a lot easier to get rid of that first term, because it makes it a lot easier having an x squared instead of a number x squared. Now we're going to complete our square. So So we're going to take half the middle term. 5 squared is 25. Add it to both sides. And then 25 over 1 equals what over 4? So if you said 100, you'd be right. 100 over 4 minus 17, that's 83. Now we're going to square root both sides, so x plus 5 equals plus or minus, and we're going to square root the top, square root the bottom. So that's 10, and then we're going to subtract 5. Plus or minus square root of 83 over square root of 100, which is 10. Now, it's up to you. You can make this one fraction or you can leave it like that, which is fine with me. But if you make it one fraction, that would be negative 50 plus or minus square root of 83 over 10. So either way, that way or the way I have it first. Let's look at 63 in the book. It says find the x-intercepts. Well, it says complete the square, find the x-intercepts. But so if you remember, you're going to let f of x equals 0 and solve for x. That's going to give you the x-coordinate on the y-axis. I mean on the x-axis. So if y is 0, y is f of x. So we're going to let f of x equals 0. That's the y-coordinate. And basically we're just going to solve this to figure out what the x-coordinates are. So let's see. Let's switch it around. X squared minus 10x minus 22 equals 0. Move the 22 to the other side. I'm going to put plus 0, plus blank, complete the square. I'm going to take half the middle term. 10 divided by 2 is 5. And now notice it's negative 10, so half of negative 10 is negative 5. Negative 5 squared is positive 25. And we're going to add it to both sides. So then we get 47. Square root both sides. So x equals, and then add 5 to the other side. So our x-intercepts are 5 plus square root of 47, comma 0, and 5 minus square root of 47, comma 0. Let's see. .47 square root is 6.85565. So plus 5. So it's going to be 11.86 if I round that 0. And then the other one will be 1.86. Okay, so that's where it's going to cross the x-axis, those 2 points.